Hello, friends. Here I am, and welcome back to my stream. Today, I am talking about a brand new type of AI which has just been announced, who are, in the words of one commentator, building a thermodynamic god AI. So it seems like a pretty wild story. I am going to take you through all of it. And our story begins with a Twitter account called Based Beth Jesus. So many of you may have heard of this person who is a leading voice in the EAC movement on Twitter, which is accelerationism. That's to say, it's kind of the opposite of doomerism, which is, the people who kind of say that they want to slow down AI. People like Liron Shapira, who I've had on the show previously, have talked about the existential risk to humanity from the acceleration of AI. EAC is kind of a counterpoint to that, which is saying that actually the moral imperative is on us to accelerate AI as quickly as we possibly can, because it can bring such tremendous benefits to us as a species. So I can kind of understand some of these points of view when you think about things like medical science, when you think about things like cancer, for example, or when you look at the protein folding problem, which has essentially been solved by DeepMind, you can start to understand how we could advance these kinds of technologies in a way that may eradicate disease. We may be able to cure cancer once and for all with advanced AI technology. And so that kind of thinking is really at the heart of the EAC movement. And one of the leading voices, as I say, was a man called Beth Jesus. So I'm going to share my screen so you can see who it is I'm talking about. Let's find him. So this guy here, Beth Jesus, chief accelerator and founder at EAC and founder of Extropic AI, who are the company who have just announced this seed round. Now, Beth Jesus was anonymous until very recently, when he was doxxed by Forbes. So you can see the article here. I'm going to share. You can see Forbes did this whole kind of expose on Beth Jesus, who, as it turns out, is a man called Willem Verdon. And Willem Verdon is a really interesting guy. So he is the founder of EAC, based Beth Jesus. He's also the founder of this company called Extropic, who have announced their seed funding. So I'm going to share my screen and show you Extropic. This is them, and this is the announcement of their seed funding round. And the announcement is just here. And the announcement has this little right through at the beginning, which I'll read out. So the era of omnipresent generative AI is imminent. Timelines have been accelerated. The future must come to pass. Extropic is building the ultimate substrate for generative AI in the physical world, building an AI supercomputer by harnessing the first principles of thermodynamics and information like an alien would. With this fundraising announcement, Extropic crosses a significant checkpoint in the timeline, a milestone in wielding the techno-capital machine to birth a core technology for our civilizational trajectory. The Extropic AI supercomputer thus begins assembling itself from the future. So it sounds like some kind of weird sci-fi graphic novel, but this is actually a thing. And what they're talking about doing is building a new generation of AI using fundamental physics. So briefly, I'll get into what it is that they're actually doing, or as far as I understand it. Now, I'm not a physicist, but I've been doing a bit of background reading. But first of all, let's just look at this guy, Willem. So he is Google. So he was the quantum tech lead at the physics and AI team at Alphabet's X. He pioneered a plethora of quantum technologies with wide-ranging applications from perception, communication, and representation learning. He's regarded as a pioneer of the field of quantum deep learning, founding what later became Google's TensorFlow quantum project. So he's clearly an expert in quantum computing, which is a very advanced field of computing, which uses this advanced understanding of quantum mechanics to build computers in an entirely different way from the way that we currently understand them. So what's important here is understanding what current AIs are built on, what current computers use, and what potentially this new kind of AI might be built on. So first of all, now I'm not an expert on building chips, but just to give you a brief understanding, CPUs are optimized for serial tasks, as you can see here. GPUs are graphics processing units. So they were originally built to process graphics in things like video games. And what they're very good at is processing lots of things all at the same time. Now, this was almost sort of stumbled upon. The AI technologies that were built on them was almost by accident. They weren't designed for AI, but they are now a big part of the reason why NVIDIA has gone stratospheric in terms of its share price, because these types of chips are really fundamental. But it looks like what Extropic are going to be doing is creating a whole new type of substrate, basically, on which to build AI. And they talk about it being based on fundamental physics. So what they're essentially saying that they want to do, and I'll share my screen again, is thermal computing. So you can see here, Extropic's doing thermal computing, and what Beth Jezos is saying is that quantum is too far away because it has to be infinitely cold, which is impractical. Whereas thermal computing is using the same kind of physics, but not with these extreme cold temperatures. So it seems to be using temperature as another variable as part of the compute. So I did a bit of digging and I found this paper from Cornell. I'm just going to make sure that you can see that on the stream. Yes, you can. So thermodynamic computing via autonomous quantum thermal machines. So here they're developing a physics-based model for classical computation based on autonomous thermal machines. So these machines consist of interacting quantum bits connected to several environments at different temperatures. So that's the key thing here. Heat flows through the machine are exploited for computing. So what they're doing is using that temperature variation as a data input. Now, what's interesting is that I spoke to Joseph Jacks on the podcast a few months ago, who was saying that there is really no source code for AI. He advocates calling it open source. Open weights rather than open source, because it's just a series of probability weights. So it's really you can store a lot of these large language models on like CSV files, like Excel files, because it's just probability weights. So if you kind of extrapolate that, what LLMs are doing is kind of using all of these probabilities across a GPU in parallel to kind of compute probabilities. And in the case of an LLM, compute the probability of what the next token is going to be. So they're predicting the next word. So presumably what thermodynamic computing is going to do is create some kind of quasi quantum computer as the substrate through which to build an AI. Now, if I take you back to the Extropic release, you can see that they are really going into a bit of detail here. So I'll read some of this. As generative AI begins to eat the world, our appetite for scalable, cheaper, faster, and more efficient compute is becoming insatiable. One then wonders, given the dawn of the generative AI first era, could we fundamentally reimagine what is a computer? One could imagine a computer which, instead of suppressing the natural entropy of the world, achieves symbiosis with it, leveraging it as an asset. One could imagine a computer which, instead of being imperatively programmed, naturally finds a way to program itself to learn representations of this world. One could imagine a computer that's so efficient that it would truly enable us to scale generative AI to the world, circumventing the need to massively scale energy production. So this is really interesting because a lot of the talk about AI revolves around scaling AI, revolves around this energy production. And a lot of people are talking about nuclear. A lot of people are talking about scaling up renewables in order to power all of these energy-hungry LLMs. So presumably, building thermodynamic compute means that they can almost make use of the kind of ambient temperature in the world as part of its compute, thus being able to scale it to a far greater degree very, very quickly. So I presume people on the Duma side may be incredibly worried by this because it just takes away another barrier to explosive growth. And at the moment, LLMs do require a huge amount of compute. What they're essentially, presumably trying to do is to remove that bottleneck to enable LLMs to grow at an exponential rate. So this would put that power in the hands of everybody all at once. Some would say that's democratizing intelligence, democratizing information. Some would say that that's a very reckless and dangerous move because it gives a huge amount of power to anybody who wants it. So I'd love to know what you guys think in the comments, whether this is indeed a very dangerous thing to be doing or whether it is in fact super exciting. It's also interesting to see that they are really trying to build a new paradigm here. So another interesting part of this is that one of the principles of AI advancing that people are starting to notice is that basically the human doing the programming actually just becomes a problem. They get in the way. So they found this when they were programming chess computers, Deep Blue, I think it was called. They started programming it with human knowledge based on what all of the chess players were saying. You need to know this, you need to know that. And they did okay. But what they actually found is that when they allow the computer to learn by itself, it actually does much better, much quicker. So it seems like what they're essentially trying to do here, they say, one could imagine a computer which, instead of being imperatively programmed, naturally finds a way to program itself to learn representations of the world. So that it seems like what they're essentially trying to do is just remove all of the human programming altogether and allow the AI to do as it pleases and understand the world in its own way. That, again, potentially very exciting, potentially terrifying. I really don't know which. I'm super excited to see how this goes. One final note that I will make on this is the other people that are involved. So we've spoken about Willem Verdon here. Next one, Trevor McCourt, Extropic CTO, was originally a mechanical engineer, worked on TensorFlow Quantum with Willem, and then they have clearly worked closely together on quantum computing. The next one, Christopher Chamberlain, principal architect, widely regarded as one of the most eminent quantum computer architects. So they've clearly got some super smart people. They've got a lot of money. It's going to be exciting to see where this goes. I would love to hear what you guys think about this new technology, this new funding, where you think Extropic are going, what you think of Beth Jezos, and essentially, I would love to hear from you about the very heart of this argument, which is accelerationism versus AI risk. Should we be accelerating AI as quickly as we can in order to solve all of the problems facing us as a species, like curing cancer, like solving Alzheimer's, like solving all of these kind of chronic diseases, like solving aging? Or should we in fact be trying to slow it down as much as we possibly can because the risk is too high? Is it in fact inevitable that if AI becomes too powerful, it will harvest us for resources, or it will fear that we're going to switch it off and therefore enslave us all? Is intelligence too powerful of a thing to let run wild? Or is in fact intelligence at its very core an amazing thing that we should be trying to create more and more of? I really don't know the answer. That is part of the reason for setting up this channel, is to try to get to the bottom of where we should be as a species and to try and explain some of these things as best I can. As I say, I'm not a quantum scientist. I don't know the hardcore programming details of quantum computing, but I'm going to be taking a closer look at this paper that I shared with you earlier, thermodynamic computing via autonomous quantum thermal machines. And frankly, I think you're going to be hearing a lot more about thermodynamic computing in the future. So that's it from me for this week. As I say, really want to hear what you guys think in the comments. Are there any experts on thermodynamic computing? I would love to get some guests on. Please drop your recommendations down in the comments if there's anybody that you think I should be speaking to about this. But for now, that's it from me for this week. I hope you all have an amazing week, and yeah, get in touch. Let me know what you think.